about measurements and conversions, correct? So we'll have the opportunity today to look into three basic units. So we'll use three what? Basic units. And these three basic units is, we'll take the mass, the basic unit for the mass, and for the length, and for the value. And the system we'll be using is metric system. For the what? We'll be using what? Metric system. So we'll have the mass, the length, and the volume. For the mass today, we'll have to the basic unit is grams, correct? And the symbol is G. Here is we have the meter, and the symbol is M. And here we have a liter, and the symbol is L. So those are the basic units for the three basic units for the metric system, and we'll go through them one by one, correct? So let's go first for the mass. The mass in your lab. Let's take the mass. So the mass you will have to weigh, correct? We have to weigh a watch glass, number one, and then you have to weigh small beaker, correct? Using two different balances, correct? So balances. We will have to weigh a mass of watch glass. You get your watch glass from your drawer, and weigh in two balances. The first balance here, called top load, which is less precise, and the other one is called, the second one, the second balance, called analytical balance, and this is top load balance, correct? And it's called this is more precise. The first balance give you about up to 4, correct? Up to 4 digits, 4 to 5 digits. So here it is. That's the reason here. So top load balance weighs up to 4 to 5 digits, correct? The analytical balance weighs 6 and more digits. So that's the difference between what two balances. And if you can give me just 1 second, I'll switch to show you how those two balances are different. So here we have one on your left. This is analytical balance, and this can be found where? Can be found inside our prep room there, balance room or prep room, or the chemicals are prepared, solutions are prepared. And the other one is the top load balance. The top load balance is less precise. Give you up to 4. And if we are lucky, we can get the 5th digits. So it's not precise. This one here can be 6, 7, even 8, depending what type of analytical balance, which is really a research balance, the left one, the analytical one, correct? So we have two balances to have to, and then we have to determine after we are done with this. So this is the picture here. Let me switch back here. And from this one here, I can then write, then number 2. I will record the mass of the watch glass, and the beaker, correct, for both balances. And I have to determine the signification of the values of both balances. Okay, guys. So, and that will show you just a table where you have to record your data. And I'm switching back again. Our data will be recorded here. So, and here it is. Our data will be, where is the mass here? Here is our data here, and we have the analytical balance, correct? And here it is. You can see that's the analytical balance, and this the other one is the top load balance, and you can get all the values and then determine the signification for both, for the beaker, small beaker, and the watch glass. Remember, all the watch glasses we have in the lab, they are not identical, correct? All the beakers are not identical. So the masses of all the beakers are different. Although the same, it says calibrated 100 ml beaker, but not every 100 ml will have the same mass, correct? So that's, you have to know that every glassware is made with different conditions, and that will affect its mass, correct? So that's the table, the first table we have to do. Watch glass and the beaker, correct? Then we have, after we are done, we have to go to, so that's the table we have to be filling for the watch glass and the beaker in the prep room, recording two different balances and record their value. Let's go back. Now we'll have the basic units of, we did the mass, and now I will go for the length, correct? The length. The length, you see the metric basic unit is meter, correct? Basic unit is meter, m. So now what we'll have here, you will have in this to determine the length and the width of object. This object here, I'm showing you here. Can you see it? This is, if you look at this is number. I mean, it's up to you, whatever you see it. I said that maybe that's number 9, correct? I see it as number 9. This is number 9. This here, we have to determine the dimension of this object. Now we are looking at this object here. Look at this, correct? In a 3D, correct? So, looking at this here, object number is 9, correct? So, this object here will determine its length, width, and height, correct? In centimeters. So, we have to determine the wooden objects length, width, and height, correct? Those are in centimeters, correct? In centimeters. So, and in doing this, you'll have to have, which is a little bit not accurate, but we'll use it at least for the crude training here. You'll take your ruler. I'm looking for a ruler here. So you take your ruler and you measure the dimension of this, correct? So if I look at this will be my z-axis, correct? Z-axis. This is my x-axis, and inside the depth is my y-axis, correct? So here it is. This is, I would say, my length. If I look at this number 9, this is my length here, correct? So, and if you look at this, I will ask somebody here in class, give me grab from a drawer, bring me a ruler, so we can measure it together and see how we measure it. Yeah. Now you can see this measurements with the ruler is very crude and it's not accurate, correct? And we have to have a special equipment to measure the length, the width, and the height, which is much accurate, correct? A Vernier caliber for a caliber looks like a wrench. That's much more accurate and precise than the ruler. But for the sake of just measuring this, and if you look at this, a ruler has two measuring, correct, system. This is an English system, and this is a metric system. The bottom is in inches, you can see, inches, and the top one in centimeters. Metric versus English. So an inch is 2.54 centimeter. So if you look here, I have 1 inch, and if you look like this, 1 inch and go up, look at this, can you see it? I can go up, one inch go up, it has to be 2.54 centimeters. So 2.54 centimeter is 1 inch, correct? So this has both English versus metric system. So as I said, it's a crude, it's not really precise. I have to have a Vernier caliber. I have special equipment to measure those to get a very good precise data. But for the sake of training, I'll go here, and this is, as I said, this one here is my length, correct? This is my length, is the same thing in the top, correct? So I will measure here. If you look at this, and you help me reading, how much it reads? As I said, this crude, how much is read? 7 point what?
We can't see.
You can see it? Sorry, I apologize. So now, I have to put from here, see, that's the beginning. So how much is it now? 7 point what? 7.8. And you can see it's 7.75, 7.8. This is not really precise, but we'll take it 7.8 to significant figure. So we say the length of this object, length, is 7.8 centimeter. Now, when you do your experiment, you will do what? Your own object. We have up 1 to 20, whatever different wooden shapes, correct? That's a rectangular one. We have squares. We have, I think, we have cubes as well. So we have different objects in the back, but measure this, and this is the length. Now the height is what? Is here, correct? That's the height. So let's go and look at the height. And this is the height, but it's very awkward to measure it like this. So I will flip it like this, and you tell me how much that is. Can you see it? Yeah. So now I'm trying my best. As I said, it's a very crude. How much is it? 9 point what? 5, less than 5. 9 point what? 4 I read, correct? So it is 9.4 centimeter, correct? Now what else is left for me here is what? What's inside. So we did what? We did the z-axis, we did the x-axis, and now we have to do the y-axis. That's what? The depth, correct? Or the width. Width or depth. So now we have to measure the width, or sometimes called depth. They're the same meaning. So let's look back this one here. This is my what? Y-axis. That's my depth or my width. So it's upward from the bottom. I'll take the top. It's a parallel and the same value. So then I'll come here with the ruler and then measure this one here. And how much is it? Somebody will tell me how much is it? Here, let me back. Here. How much? 3.8 or 9. I would say maybe 8.5. 3.9. So 3.8 centimeter. So you can see that's very difficult to get accurate measurement with this using this ruler. So now we practice as an exercise to measure the length, the width, and the height of an object with an object, which is really not cube, not a cube, not any other object, but this is rectangular. And after that, what we have to do, we have to determine its, and that will come to the next one, its volume, correct? What's the volume of the rectangular object we have? Volume will be length, correct? Multiplied by height, multiplied by height, multiplied by width. So this one here, 7.8 centimeter, multiplied by 9.4 centimeter, multiplied by 3.8 centimeter. And how much is it? Somebody had calculated?
278.616.
278? 278? 278, and how much?
0.616.
0.616 centimeter cube, correct? Cube. That's a volume here. Now, question is this answer is correct? That's the final answer? No. Our answer has to have how many significant figures?
2.
We have here, let's go for this. This is 2 sig figs, 2 sig figs, correct? And this is 2 sig figs, and this is 2 sig figs. The rule is, when I have multiplication, so I have here this multiplication and division, I have to have least number of sig figs, correct? Is controlling the rounding up. Is controlling the rounding up, correct? Are you following?
Mm-hmm.
So I have to make from this is how many? 6 sig figs, correct? This is 6 here, 6 sig figs. I have to make out of it how many? 2. So it's up to me. I can do it the zero method way or the scientific way. So the easiest one, if I have 2, well, I will say myself, maybe I have to do scientific way easy. I will move, it's up to me whatever I want to do, so it's many possibilities. But I will move the digit, say 2, correct? Move the decimal. So it will be 2 point. So 2, and then the decimal I move it. And then I have the 7, here is 8, correct? 8, 5 and above, rounded and carried on as 1. 2.8, and I move the digits, how many? How many I move the digits?
2.
2 centimeter cube. So I have 2.8 8 10 power 2. So I move the decimal 2 digits. Because I move the decimal to the left, the exponent has to be positive. How many digits I move the decimal? 2 digits. Then the 2 is the number of the digit. So the 2 here, number of the digits of decimal. Moved into. So it moved 2 digits. So it moved into. So it has to be 2. And the positive to the left is positive, correct? So this is the correct answer rounded off. So this is for the length and the volume, correct? However, I have volume is centimeter cube. So then I said to myself, what is the relationship between, because the next step is to determine the volume of this liquid. So we'll not open those are sealed, you can see, wax on the top of the graduate cylinder, don't open them. We will have to measure those solutions here, if you look at them here. And these solutions are labeled. This is the blue one is A, the red one is, red is B, and then light blue is C. So we have 3 of those and we have to measure the volume. It turns out to be, and this one here, 3 here, it turns to be that 1 centimeter cube is equal by definition 1 ml. Remember, this is basic unit called liter, correct? And this is basic unit meter, correct? And it is cubic in this case. So cubic meter, and this is correct. So 1 centimeter cube is 1 ml. Are you following? So it means if I have a cube here, so imagine this is a cube here, and this cube here has, so all dimension is 1 centimeter, length, width is 1 centimeter, and the height is, so the height here is 1 centimeter. So this is here, and this is here. So I have volume of the cube is height, length, multiplied by width, correct? And this is, H is means height, L means length, W means width. And this turns out to be, believe it or not, 1 centimeter multiplied by 1 centimeter multiplied by 1 centimeter is 1 centimeter cube, correct? So if I fill this cube with H2O, it turns out to be what? It turns out to be filling exactly 1 ml, correct? Exactly what? 1 ml. So when the cube, let me write it down here. When this cube is filled in, correct, with pure H2O, it gives us 1 milliliter exact, correct? Exactly 1 milliliter. So therefore is 1 milliliter is 1 centimeter cube. So 1 milliliter is 1 centimeter cube. Now, I think one of you here is taking what they call nursing, correct? In nursing, the 1 centimeter cube here, if you look at the centimeter cube, it gets 1 cc, correct? 1 cc means what? That's the drug the doctor or the nurse has to give it to the patient, correct? This is 1 cubic, correct? 1 cubic centimeter, correct? 1 cubic centimeter. Everyone's following? So if I say, the doctor had given the patient for this medication is 2.5 cc. Then the nurse say 2.5, this is 2.5 milliliters, correct? So 2.5 cc is 2.5 ml, and it is 2.5 centimeter cube. You get the idea? Now sometimes we don't have in the lab to measure the cc exact or to measure 1 ml. A graduate cylinder, you can see, is very hard. Barely you can measure the graduate cylinder 1 ml. The only thing you have to use pipette or burettes. But you need this quick, rough and crude measurements. And we say this is 20 drops. This is 4 here. 20 drops by the eyedropper is equivalent, not exactly, approximation. This is approximation. Approximation is 1 milliliter or 1 cc or 1 centimeter cube. So you get the idea here? So now, in the lab, you will see, I'll tell you, add, we don't have the time, so just add 2 mL, correct? 2 mL of this. So you can roughly, because it's not accurate, just qualitative, not quantitative, qualitative. So how much you will add? 40 drops, correct? Using the eyedropper, correct? Use the pipetter or the eyedropper. So 40 drops, and that will be 2 mL or roughly here. And this is 2 centimeter cube. Roughly here is 2 cc. Everybody is following now? Good? Now, let's look at those, at each of those. Now, we did the mass, we did the length, measurement of the object, the wooden object, correct, and measured its volume. Now, how about now, we don't have the centimeter cube, but we have to have in milliliters. So we want to measure this. Can you see it now here? Can you see it? Maybe I have to make it bigger here a little bit. Here it is. So I want to measure this. Now the problem with this, measuring it, see the meniscus? Somebody can see the meniscus? Can you see it? That will affect our reading. We have to have our eyes at the bottom of this meniscus. Can you see it? Our eyes has to look here, at this meniscus. Can you see it? This meniscus here, I'll just show you where the meniscus is. Our eye has to straighten up and read the bottom of the meniscus. So, and this, that will write our errors. And I can show you here, just if I look here, here it is, and that's written here in the book as well, in the procedure. So this is the meniscus here. This is called what? Meniscus. This meniscus means curvature. Curvature, yeah. That's it. Curvature here, this is a curvature here. We have to look at, our eyes has to come and look at here. Our eyes have to look here. At the bottom of the meniscus here. This is bottom of meniscus. Now, the curvature here, the problem with the meniscus is if I go and look at the top, correct? And this is the correct. This is correct here. If I come and look at from the top, the meniscus, my eyes, this is the meniscus here, correct? This is looking here at the top, what will happen? My eye will come and look what? Lower value, correct? Lower value. And this is not correct. Not what? Correct. Everybody's following? If I can come back and put my eyes here, then I read what? This is higher. So this is higher, and this is lower. And this is not correct either. So this is not correct. So it has to be what? It has to be 90 degrees perpendicular to the meniscus. So 90 degrees, so it has to be, here it is, 90 degrees perpendicular on the bottom of the meniscus, bottom of meniscus. And this is just mentioned here in the discussion, and thus you have it here. Let me just switch in a minute here, just show you here. This one here, and this you can see here. If I can just show you here, that's what the mistakes you have. If you go higher, your eyes are higher than the bottom of the meniscus, the lower value. If you go at the bottom of the meniscus, you read higher value. It has to be 90 degrees perpendicular, correct? So, now, you tell me what's the value here. Can you see it? Let me switch our document camera here. So this one here, it reads what? Somebody will tell me here how much it reads? Somebody, so I can't, if I see it, I would say lower, higher value, but here, exactly to my eyes, sometimes I cannot read it, correct? I cannot read it like this. So what I will do here in this case, I have to come up with the trick here. So I put a piece of paper, here, let's have a piece of paper, and then just have the piece of paper flipped, and then another flip here. Now this way here, I have to get all the light reflection out of my way, and then I can do it this way. Can you see it here, please?